The ethanol used for medical purposes is called USP ethanol. It is an aqueous solution that is 95% ethanol by volume. That means that if I have 100 milliliter of solution, then 95 milliliter of that solution would be ethanol. At 20 degrees Celsius, pure ethanol has a density of 0.789 grams per milliliter, and USP ethanol has a density of 0.813 grams per milliliter. What is the mass percent of ethanol in USP ethanol? Now remember, USP ethanol is a solution that contains 95% ethanol by volume and 5% water. Yeah. And if we're being told that a solution is 95% by volume, like I said in the video, I assume that if I have 100 milliliter of solution, that I have 95 milliliters of that solution that is ethanol. That is different from saying that if I mix 95 milliliters of ethanol and 5 milliliters of water, then I will get 100 milliliter of solution. The reason is that ethanol dissolves in the water, so the last result would be a smaller volume than 100 milliliter. Just for the sake of the question, 95% by volume would translate into 95 milliliters. Now, how do I go about it? In order to find the mass percent of ethanol in USP ethanol, I first need to find the mass of ethanol in that solution, and I need to find the mass of ethanol over the mass total of the solution. And in order to find it in percentage, I will multiply this by 100% to get the mass percent of ethanol in the solution. So I know, like I wrote here, so let's write it in dimensional analysis, that I have 95 milliliters of ethanol for every 100 milliliters of solution. And I'm also given that the density of ethanol, of pure ethanol, at 20 degrees Celsius is 0.789 grams per milliliter. That means that for every milliliter of ethanol, I'll have 0.789 grams. So in 95 milliliters, I will have 0.789 grams of ethanol for every 1 milliliter of ethanol. And so the number that I get is that I have a total of 74.955 grams of ethanol for every 100 milliliters of USP ethanol. So now that I found the mass of ethanol, remember I needed to find the mass, so I have this value, and now I'm looking for the total mass of the solution. So where do I find this? In this question, I'm also given the density of USP solution, of USP ethanol solution. So USP ethanol has a density of 0.813 grams per milliliter. So I know And I want to find for 100 milliliters of ethanol, because that's what I decided the volume of my solution is. So in order to do that, I know that I have 100 milliliter of USP ethanol solution. And I know that the density that I'm given here is that for every milliliter of the entire solution, I have 0.813 grams. So 0.813 grams of USP ethanol for every 1 milliliter of USP ethanol. Now the units of milliliters are canceling out, so I'm left with 81.3 grams of USP ethanol for every 100 milliliters of USP ethanol solution. So now that I know the mass of ethanol in 100 milliliter of solution, and that I know the mass of the entire solution as a whole, I can solve for the mass percent by dividing the mass of ethanol by the mass of solution and multiplying by 100%. So 74.955 grams of pure ethanol for every 81.3 grams of USP ethanol times 100% will give me 92.19557%. Now let's look at our sig figs. I know that the values that I'm being given are two significant figures because I calculated for 95 milliliters of ethanol, because the value that I'm given is 95% ethanol by volume. So I'm looking for two significant figures. So the answer is 9.2 times 10% of ethanol. In this section, I'm being asked to find the partial pressure of ethanol above a solution of USP ethanol at 20 degrees Celsius. So first of all, this is a Raoult's law question. The question says, at 20 degrees Celsius, the vapor pressure of ethanol is 44.63 torr, and the vapor pressure of water is 17.54 torr. What is the partial pressure of ethanol above a solution of USP ethanol at 20 degrees Celsius? So first of all, to help us visualize this, I drew here a beaker that contains a solution of USP ethanol. And what I'm being asked is to find how much of that total pressure above the solution is due to ethanol in the solution. So for simplicity, I separated the two. See, the ethanol is orange and water is yellow. But in reality, of course, that the two vapors are mixed. But here, just for simplicity, I separated the two. So I need to find the partial pressure of ethanol, which is the orange. Now, According to Raoult's law, the partial pressure of a component in the solution is equal to its mole fraction in the solution times the vapor pressure of the pure component. So if I'm given the pure pressure of the component, so I need to find the mole fraction and then multiply it by the pure vapor pressure of the component to find the partial pressure of ethanol. So let's do this. I have 92% of ethanol by mass. So for each 100 grams ethanol solution, 92 grams out of that is going to be due to ethanol. So again, I'm continuing. 1 mole of ethanol has 46.08 grams. That's the molar mass. So that gives me that in 92 grams of ethanol, I have 1.9965 moles of ethanol. Now, because I have 20 degrees Celsius, so I'm looking for two significant figures, so I'm going to keep track of that. That's for every 100 grams of solution. In order to find the mole fraction, I need to find the number of moles of water. So if 92% of the solution by mass is ethanol, so the other 8% is going to be due to water. So from 100 grams of solution, I will have 8 grams of water. And I do the same for water. 1 mole of water has a molar mass of 18.02 grams. So that gives me 0.44395 moles of water for every 100 grams of solution. Now I have the moles of water and I have the moles of ethanol. So all I need to find is to find the mole fraction of ethanol. The mole fraction of ethanol equals to the number of moles that I have of ethanol over the total number of moles in the solution. So that gives me that the mole fraction of ethanol is 0.818. Back to Raoult's law, which tells me that the partial pressure of ethanol equals to the mole fraction of the pressure of pure ethanol, which we're giving in the question the partial pressure of ethanol to be 36.511 torr. And I have 2 sig figs. Remember, I have 2 sig figs, 92 grams, 3.7 times 10 torr, the partial pressure of ethanol. In this section, I'm being asked, what is the vapor pressure of USP ethanol above a solution of USP ethanol? So if this is my solution and this is the vapor pressure due to ethanol and this is the vapor pressure due to water, I'm asked for the total vapor pressure, which is the partial pressure of water plus the partial pressure of ethanol. I found the partial pressure of ethanol, and now in order to find the total pressure, I need to find the partial pressure of water, which I know equals to the mole fraction of water times the vapor pressure of water, of pure water, when it's not in the solution. So the mole fraction of water, remember that we found here 0.44395 moles of water. And I know that the total moles in the solution is the moles of water plus the moles of ethanol is 0.181913. And remember, I'm carrying the significant figures from the previous. That's the mole fraction of water times the pure pressure of water. I got this in the previous section. And then I find that the partial pressure of water is 3.0 torr. The pressure total in the solution equals to the partial pressure of water plus the partial pressure of ethanol, 3.0 torr plus 3.7 times 10 torr. So the total is 40 torr. So here we're being asked, what is the mole fraction of water in the vapor above the solution? So remember, according to the gas laws in chapter 5, a mole fraction of a gas equals to its partial pressure fraction. So what I'm doing is I take the partial pressure of water vapor, which is 3.0 torr, over the total pressure, which I found here, 40. That equals to the mole fraction of the vapor, which equals to 0.07526 figs.